Hello, my name is Patrick Galbraith, and today we are going to talk about the 10 most valuable open source observability tools. I've been around for many years now. I started out in my technical career in the US Navy, working on electronics for fire control, weapons fire control systems. I've written two books. One of them is listed here. It's the Chinese translation. I have worked in every possible field you could think of, from databases, programming, DBA, SRE, DevOps, architecture, whatever needed to get done. My website is patg@patg.net, and my email address is listed there. So what is the first important thing about this talk? What exactly is observability? Observability is the ability to measure internal states of a system by examining the output data it generates. There are a lot of different terms for observability, and it can be a bit tortuous, and sometimes it seems that terms overlap. But it's mainly about being able to see the state globally of everything. It's quite often associated with distributed systems. It's all about knowing whether there's a problem or whether it's imminent or developing, knowing how well utilized your virtual or physical resources are, and having the big picture of performance and availability. Observability is a property of a system, just like functionality or testability. I often use kids analogy. Back in the 80s, when I was of age in high school, there was an ad on TV that said, come on, it said, do you know where your kids are? I think of that as observability for kids. Where are the kids? What are they doing? Are they at a kegger, which was popular back in the 80s in the US? Nowadays, it's, are they home? Are they on screens? What are they watching on those screens? It might not be exactly analogous to programming, but to IT, but I find it works quite well in describing what observability is. Observability, it comes into play with a new paradigm with containerized applications, scattered plethora of microservices that are interdependent, logs, and you want to know what your logs are, traces, metrics. Logs, they're the output of different applications, different systems. Traces are when something breaks, or if you choose to have something in your code to show where something happens, that you know what's happening, where in the code it's happening, so that if there's a problem, you could exactly point to where in the code it had a problem. And then, of course, there's metrics. That's just a lot of digital data showing you the state of things and being able to interpret that. So this was a very difficult task because it was top 10, and I kept adding one, and it would go up to 12. And then I thought about it and gave it quite a bit of thought, and I came up with this list. Some of these are collapsed into categories or how they're collecting data, but the ones we're going to discuss in this are Prometheus, Thanos, Grafana, Loki, PMM, Persona Monitoring Manager, Elastic Stack, Victoria Metrics. I'm going to mention two projects that use eBPF, which in itself is a wonderful functionality within the Linux kernel that allows you to have a lot of visibility as to what's happening at a very low level without a lot of instrumentation having to be inside of the code. Jaeger, Fluentd, and Signos. First of all, I'm going to start out by talking about OpenTelemetry. This is a collection of APIs, SDKs, and tools used to instrument, generate, collect, and export telemetry data, metrics, logs, and traces to help you analyze your software's performance and behavior. The whole idea of this is that it provides a standardization that is ubiquitous, and it makes it so that your data is portable. The OpenTelemetry website listed here is an excellent source of finding out exactly what OpenTelemetry is. That being language SDKs that you can use to instrument your code. Know about what the library ecosystem that there is that implements instrumentation for the common libraries and frameworks. About the OpenTelemetry collector, many of the tools we're talking about here use that, or use collectors that have been updated to use OpenTelemetry. One of the important things to think about OpenTelemetry is that you own the data you generate, and that it's yours, and that there's no vendor lock-in, so that you can switch systems if you choose to do so. And you don't have to learn numerous different APIs for how you're going to instrument your code. So the first tool we're talking about is Prometheus. The category of Prometheus, as the title here shows, is metrics at scale. The use case for it is applications and infrastructure metrics. The key features of Prometheus are: it collects and stores metrics as time series data. It has a backing database with reliability in mind. It implements PromQL. It's a query language, much like SQL, but for metrics data. It's a pool-based model. There are alerting rules so that you can use it to alert when there are problems with the system. It integrates well with other tools. You can also push time series using Push Gateway. Targets are discovered via service discovery or a static configuration. And I have this section here under the hood. I like to know how things work, so that's why I came up with this section for my slides. Prometheus is written in Go. It's a time series database written by SoundCloud back in 2012, I think it is. It's installable as a Kubernetes operator, Helm chart, or on a host with Ansible, manual, etc. There are numerous ways of doing it: Docker containers, Docker Compose, Docker Swarm. Here are the Prometheus components. First of all, we have the Prometheus server. It's the core component. And this is for retrieval and storage, the time series database. The Prometheus server scrapes metrics from instrumented services or systems. It stores this data as time series data in its local storage. Data is pulled from jobs and exporters or via service discovery. Then there's service discovery. Service discovery is just essentially a part of Prometheus that utilizes whatever it can to find out what targets there are to observe, whether that's Kubernetes, Console, DNS, AWS, or other cloud platforms. And of course, you can also specify it in a file. Sometimes you have a very small setup for Prometheus, and it only monitors a few servers, and you'll have it inside of a YAML file listing the targets that you're going to monitor. There's metric scraping. It does pulling metrics, where it pulls metrics from jobs exporters periodically. These jobs can be services that expose the metrics or exporters that expose metrics on behalf of other systems. And you use scrape configs to specify those. Push gateway. So the push gateway, this is if you're using a push-based model. Prometheus generally works in a pull model, but for short-lived jobs that might finish too quickly for Prometheus to scrape their metrics, a push gateway can be used. Alerting and notification. Alert Manager. The purpose of Alert Manager is it generates alerts based on predefined rules that fit a certain criteria. These alerts are sent to the Alert Manager, which handles the delivery of notifications to different notification channels. Alerts can be routed to various communication platforms like PagerDuty, email, Slack, you name it. Data visualization. Prometheus Web UI. Prometheus comes with a basic built-in Web UI where you can query metrics using PromQL or view graphs of metrics over time. Where you really want to get some visualization of what Prometheus is doing, you want to use Grafana. And Grafana uses Prometheus to pull metrics and generate those when it does a query. And then, of course, we have the time series database. This is a time series database on disk, and write to disk. It stores. This storage engine allows efficient storage and retrieval of time series data. Thanos, it's a global metrics aggregation. Its purpose is to globally aggregate metrics at scale. That being is that it federates Prometheus. It's to extend Prometheus applications and infrastructure metrics. So what it allows you to do is have a global query view of all metrics from as many Prometheus instances as you require. Because trying to do this without something like Thanos is very tedious and very difficult to do. It also provides long-term storage of metrics in Object Store. It provides high availability of Prometheus. And under the hood, the way it works is it has a sidecar to connect to Prometheus, a store gateway to expose the bucket content. That's the long-term time series data that it's storing. And it has a compactor that compacts and downsamples data, a receiver that receives data from the Prometheus write-ahead log, much like analogous to Postgres write-ahead log. And then it has a ruler that evaluates recording and alerting rules. And then a query gateway, which provides Prometheus API, this being for Grafana, for programs that utilize this. Anything that requires a Prometheus API, so you get that global view. And of course, here's a graphic of Thanos, how it works. First of all, we have the Thanos sidecar. It runs alongside each Prometheus server, acts as an intermediary between Prometheus and Thanos and other components. Its function is that it has a store API, exposes Prometheus data through a store API, has a shipper, uploads Prometheus time series database to long-term object storage, allowing offload older data to cheaper and scalable storage options. Has a remote read API. It enables remote reads for querying recent data, still stored locally in Prometheus time series database. Then, of course, we have inside of this diagram, the Prometheus server. I won't discuss that at length. We know what that already does. Object storage. This is for the long-term storage of data. This can be S3, GCS, Swift, MinIO, whatever provides object storage. The function on this is a Thanos sidecar periodically uploads TSDB blocks from Prometheus to the object store. And then the Thanos store gateway. The purpose of this is responsible for querying metrics stored in the object storage. Thanos query. Thanos query is the central component that allows querying across multiple Prometheus instances and object storage. It's the thing we like and is magical. Function. Store API to collect multiple Thanos store gateway sidecars using the store API to retrieve both recent and historical data. Prometheus Query API provides a unified querying interface for all Prometheus instances. And then a web UI, which allows the user to interact and do all of the PromQL queries they want to run that are connected to all data sources. It's making it easy to analyze whatever data they want to look at, spanning across different Prometheus instances and long-term storage. Then there's Thanos Compact. It's responsible for compacting time series blocks stored in object storage. Thanos Roller. The purpose of this is for evaluation of alerting and recording rules. Then we have a Grafana API and clients. That is for the same thing that we mentioned in Prometheus, being able to connect to that and be able to run API calls to run queries. So how it all works together, you've got data flow, Prometheus servers scrape and store metrics as usual, and the sidecar uploads these metrics to an object storage and long-term storage. Querying, Thanos query federates these queries. Downsampling and compacting, Thanos compact optimizes and downsamples data in object storage to reduce storage costs while still providing useful historical data for queries. Rule evaluation, Thanos Roller enables centralized rule evaluations that can pull data from multiple sources. The next tool, this is the visual component of what Prometheus is gathering. Not just Prometheus, other systems as well. Grafana, beautiful visualizations. Category is data visualization, use case for metrics and trace visualization, sharing dashboards and alerting based on criteria of the data in those dashboards. Features, it provides beautiful dashboards to collect, correlate, and visualize data such as metric traces and logging. You can from Grafana Labs website, there is a link to getting different dashboards should you want them. There are numerous dashboards that people have already put together. You can also build your own. You can also alert on metrics and logging events, data source plugins for being able to query time series databases and other data sources like Loki and Elasticsearch, PostgreSQL, etc. It's Apache licensed. Under the hood, SQLite DB for the users. I found this out because I had done an install and the password wasn't working, so I went in there and changed it. Connects with and also connects with Prometheus to get the data and be able to visualize it, or other systems, Graphite. Installation, you can use a Helm operator, Docker, Windows, and Mac OS and Linux packages. Grafana Loki. This is Grafana, but for logs. And its key features are horizontal, it's horizontally scalable, HA multi-tenant log aggregation system, persistence to object storage, much like other components we've already discussed, real-time log tailing, metadata index with your logs labels, native integration with Prometheus, Grafana, and Kubernetes, log storage. So the logs are stored by indexes are Grafana style labels to distinguish log streams in time series database. Compressed logs, chunks stored in object store, S3, so on and so forth, containers of log entries for a specific set of labels. So you have the indexes, which are the labels, and then you have the actual log data, which is chunks that are stored, as mentioned here. And they're pushed to Loki endpoint by client Grafana Alloy collector. You can use an OTel collector and Prometheus, and they're also third-party compatible with Loki. Under the hood, installation via Helm, Docker Compose, Linux packages, and one that I read about called Tonka, and this is one that Grafana Labs uses for their installation. And here is a diagram of Grafana Loki. As I mentioned, we have the ruler on the left here, and the purpose of the ruler is for log-based alerting rules. It runs queries against Loki, conditions met, and trigger alerts. We have over here the distributor. The distributor, this component, this is the right path. We have the distributor. It's responsible for reading log data from clients or agents such as Prometheus and validates the log data. Then it forwards it to multiple ingesters. The ingester, purpose of the ingester, it's a component that processes the received logs and temporarily stores them in memory. It's responsible for creating the log chunks and storing the index information. After the ingester processes the logs, it writes the chunks and index in long-term storage, such as object stores like S3 and GCS. Ruler. The ruler component handles alerting and recording rules. It reads the log streams and evaluates them based on predefined rules and triggers alerts accordingly. Query front end. So this is the read path. We have the query front end. This is the entry point for user queries. This distributes the queries to the queries after processing it. It handles query scheduling, retries, and optimizations. Then we have the actual querier. Queries are responsible for executing the queries. It retrieves the relevant log chunks and indexes from storage. Cache layers, and this is memcached. It's used as kind of a result cache, and an index cache, and a chunk cache. And we've already mentioned what the indexes and chunks are. It's a bit like a query cache in MySQL or even in Postgres or other database systems. We have cluster services. Cluster services right here. We have the compactor. This is, I already mentioned this. It compacts smaller chunks of logs into larger ones, reducing storage costs and improving query performance, and merging smaller pieces of log data. And then there's Console. Console provides a service discovery and other cluster-related management tasks. And then, of course, storage is S3, or S3-like stores, or any object store. PMM, Percona Monitoring Manager. So I've included this in the category with Prometheus, Grafana, and all of these because it uses many of these components. And I love Percona Monitoring Manager. Having been a database administrator, this tool has been invaluable for me trying to find problems in the system, being able to identify queries that are slow and what might need to be tuned. So the category of this is database observability. The use case is database administrators, DevOps teams, SREs. Features: to be able to monitor database health, perform tuning, alerting, replication lag, tracking, RCA database outages, it also integrates with backup tools. There are a whole bunch of other features that I'd like to put in here, but it would have made the slide a bit tedious to have to go through. And the purpose of this is for me to talk to you, not to have you view my slides. but it supports many of the major databases: MySQL, MariaDB, PostgreSQL, MongoDB, and more databases. It's powered by Grafana. It allows users to create and customize dashboards for specific monitoring. It also comes with some really nice dashboards. It also has a listing of all the different queries that you can look at and see what their ranking is and what their performance and how slow they are and whether they need tuning or not. Under the hood, there's the PMM server itself. There's PMM client, which runs on each of the clients running the databases. There's Grafana, and there's a query analytics engine. And alerting, just as with Grafana, alerting is based off of numerical criteria, hitting certain thresholds as to whether you want to alert, or even binary thresholds such as replication is broken. Elastic Stack, aka ELK. It's interesting. When I was putting this slide for a while, but and then Beats came along later, but you don't have the B in there, so ELK B maybe is what it ought to be called, but ELK is what it's known as. And the use case for this is full featured observability stack. This is soup to nuts observability. Key features are Elasticsearch. It's a search engine and JSON store based on Apache Lucene. Cache ingestion of logs, open source data collection, Kibana, and then also has Beats with foreign data shippers. And under the hood, it's Elasticsearch, Java based on Lucene. Install Linux packages, Helm, ECK, Cloud on Kubernetes, Docker Compose. Victoria Metrics. This is another great tool. Its use cases: high performance time series database for observability and scaling monitoring for large infrastructures, long-term storage of Prometheus metrics suitable for cloud native applications. The key features are it's fast and efficient, ingestion metrics of any scale, native support for Prometheus API, retention policies with compression for long-term storage, multi-tenancy, handling of data of multiple sources, built-in alerting, and data deduplication. Under the hood, it's written in Go for performance and efficiency. It's optimized for cost-effective disk space usage with advanced data compression, single node or horizontally scalable architecture. And it also supports distributed tracing and logs. Here's a graph. I won't go into this. It's pretty self-explanatory of how it works. eBPF. So eBPF is really excellent for being able to, for observability. It allows, I won't read every bullet point here, but the purpose of eBPF is that it provides hooks into the kernel so that you don't have to instrument your code. It just uses eBPF to pull data out of the kernel as your program runs and certain interactions happen with the kernel. Cilium is the first project that I know of that used eBPF, and it provides networking, observability, security for Kubernetes. It provides networking, observability. It provides security. It also provides a network layer for Kubernetes itself. Under the hood, uses eBPF programs. Per node Cilium agent is a daemon set and a Cilium CLI. And one of my favorite tools is CoRoot. Its use cases: observability, alerting for anything. It uses eBPF, metrics and log traces, continuous profiling, SLOAs, alerting, and predefined dashboards and inspections. It has a service dependency UI, which I love, and it can read from the Prometheus API, host or Kubernetes. It can be installed. Under the hood, eBPF, and it uses ClickHouse database for storage. Deployment is host, on host, Debian disks, Kubernetes, Helm, Docker Compose, or Swarm. And the demo is here. It's really quite wonderful. The UI that it provides. Service map is one of my favorites. And you can click on each item in here and it tells you something about that item. Go back. You see traces, nodes, deployments, costs, and so much more. Jaeger. This use case is distributed tracing, key features or analysis of service dependencies, monitor distributed workflows, ability to find and fix performance bottlenecks, and track down root causes. Under the hood, it uses ClickHouse for remote storage server. And there's a ClickHouse plugin for Jaeger ClickHouse or OpenTelemetry collectors, ClickHouse exporter. There are a number of ways you can run Jaeger. One of them is to use Kafka because of its being a persistent message store. And it's like so many other things where you have a host or container and you have a Jaeger collector. You can also use the OpenTelemetry collector if you choose to do so. And then that can feed into Jaeger collector. This diagram, kind of shows two of the main approaches for Jaeger. I won't go into that for time constraints. FluentD, it's a unified logging layer. And this is all about logging. Its key features are unified logging. You can store it within a database of your choice. It's written in C and Ruby, has a pluggable architecture, parser, formatter, and buffer and storage. It processes 13,000 events per second. Has a very easy installation, and it's an alternative to Splunk use case, logging and alerting, log analysis to various DBs. Under the hood, it's written in C and Ruby. Plugins installed as gems, and the installation is host, RPM, deb, MSI, gem, source, so on and so forth. Also is, Ruby gems. Kubernetes daemon set. Runs as a daemon set instead of like an application like so many other ones do. SigNoz. There's a talk being given within this conference about SigNoz and many of the other ones. The key features are open source. It's an open source observability tool powered by OpenTelemetry. SigNoz is really developed with OpenTelemetry in mind. It's for application performance monitoring, log management, distributed tracing, alerts, and the use case is to be able to monitor applications and infrastructure to get insights. Under the hood, its backend is in Go, Front, React, and TypeScript. Deployment using Docker, Compose, Swarm, and Standalone. You can also install it on Linux via scripts per vendor, Kubernetes, and Helm. And its database, as I mentioned, is inside of ClickHouse, which is a wonderful database for OLAP database for data like this that's pulled out of, observability platform. And the long-term storage can also, there's an optional one for S3. Here's a diagram explaining this. There's just some primary, there's OpenTelemetry collectors that go to the SigNoz OTel collector, and then that's written to ClickHouse. And then there's a query service, much like Prometheus has its query service to run queries against ClickHouse. And then there's an alert manager to, if there's rules defined for alerts. And then, of course, there's a front end, a UI for people. And then last of all, I have a picture here of the different observability tools, logs, metrics, and traces, and where each of these tools falls in terms of what they're best at doing and whether they overlap or not. And as you can see, there's some that are right in the middle there. Co-write is right in the middle. The one that seems to cover everything is SigNoz. I've included Datadog in there because much of what we're talking about is some organizations are looking for a way to save costs and use open source tools as opposed to something like Datadog, which is a great tool. Some people want to be able to roll it themselves. So this shows you what each of these tools does and where they fall and how well they might fulfill what Datadog does. And at this point, I'm sorry toward the end that we've been a little bit rushed, but I spent a little bit more time in the beginning talking about Prometheus. So you may have some questions to ask, and I'd be more than glad to answer them at this point.